Hello, everyone. Good morning and good afternoon, and thank you for joining this monthly demo from Portworx. I see a lot of people still joining us. It's top of the hour. Maybe we wait a minute, 60 seconds, and then we can get started and talk about what we have for you for the next hour, what we have planned for you for the next hour. So I'll put myself on mute, and we'll be back in a minute. Okay, I guess we can get started now. We are a couple of minutes in. Again, thank you everyone for joining this webinar and good morning and good afternoon. Today we are here to talk about how you can architect a complete data protection and data portability solution with Portworx, and specifically PX Backup, which is one of our product offerings. My name is Bhavin Shah. I'm a technical marketing manager with the Cloud Native business unit at Pure Storage, which is also the Portworx business unit. You can find me on Twitter using those two handles. Ryan and I also do a podcast called Kubernetes Fight, so you can also subscribe to that. And even though I'm the only one talking today, we also have Ryan on chat. So as we are going through slides and the demos that we have for you, feel free to put questions in the Q&A panel, and then Ryan or I will answer those as we go along this hour. So the plan for this next hour is to have a few slides. I think we have around 10 slides for you, where we talk about data protection for Kubernetes, why it's different, why you need a modern solution, and stuff like that. Then we have 3 different demos that will help us to reinforce the point or reinforce the value around having a modern data protection solution when you're dealing with containers or when you're dealing with Kubernetes. 3 demos, but I was not brave enough to do all live ones. I think I have 1 live demo and 2 of those are recordings. So we'll go through all of those as part of this presentation. But with that, let's get started with the slides. I'm hoping everybody can see my screen. If not, pause me, just put it in chat or Q&A and we'll get it fixed. But
looks good. Looks good to me, Bhavin.
Thank you, Ryan. And okay, so we all know that containers and Kubernetes are gaining a lot of momentum. They have crossed the chasm. If you are following the CNCF surveys or attended like last KubeCon and stuff, so we definitely are at a point where we need a solution that can help you deliver that modern data experience that cloud native applications require. I think based on the last CNCF survey, around like 60 or 70% of the survey respondents were already using Kubernetes or a managed Kubernetes service from one of the cloud vendors out there. And like I think the breakdown was around like 39% for Amazon EKS, and other vendors did follow that. But one of the challenges that frequently comes up when we are talking to people who are running Kubernetes is around storage and data management. So here at Portworx, we have a full portfolio of products that can help you not just with the basic Kubernetes storage layer, but also the other aspects or other modules that are required to have a full-fledged enterprise-grade solution for your Kubernetes cluster, regardless of where they are running. So they can be running inside your own data center, on your bare metal or virtual machine based clusters. They can be running on any public cloud managed offerings, any infrastructure, any Kubernetes distribution. So you might be using EKS in the cloud or maybe using VMware Tanzu on-prem. Portworx can help you with the Kubernetes storage aspect, regardless of where you're running your containerized applications or containers. As part of the complete Kubernetes data services platform, we have 6 different modules. The primary one is PX Store, which is a software-defined storage layer that runs on top of your Kubernetes cluster, is deployed as containers on the same Kubernetes cluster, and allows you to provision or dynamically provision block and file-based persistent volumes for your stateful applications that are running on that Kubernetes cluster. Then we have PX Backup, which is the main focus for the next hour, where we'll talk about how PX Backup provides that end-to-end Kubernetes native data protection solution. Again, PX Backup is a tool that was built from the ground up for Kubernetes, rather than us trying to retrofit something that already existed just for containers in Kubernetes. Next, we have PXDR. Again, as part of working with many of our enterprise customers, we do recognize the fact that just having a backup snapshot stored somewhere is not enough when it comes to maintaining application uptime. There are certain applications that customers run in production that require those zero RPO or recovery point objective, and you need a solution that can help you meet those SLA requirements. So we have PXDR as an additional module that you can use to build those synchronous and asynchronous disaster recovery solutions for your applications, for your tier 1 and tier 2 applications that need those kind of requirements. We also have PX Migrate, which helps you seamlessly migrate your applications from on-prem to the cloud, or between 2 clusters that are running maybe in different regions in the same cloud backend, but that's available as an additional module as well. 2 additional things we have is PX Secure. So this helps you create a secure Kubernetes storage solution. This has things like role-based access control, authorization, authentication. It also gives you the ability to encrypt your data at rest. So that's available. All of those security capabilities are available through PX Secure. And then we finally have PX Autopilot. And this is where if you're running your Kubernetes clusters in the cloud or even on-prem, you don't need to start from an over-provisioned cluster from a storage perspective. So you don't need to commit and buy hundreds of terabytes or petabytes of storage for your workloads that might only need a few gigs or few terabytes to start with. You can start small, and then using Portworx or PX Autopilot, you can scale your storage as your application scales. So if your application demands more and more storage, PX Autopilot allows you to create rules that can help you expand your underlying persistent volumes or underlying storage pools automatically in response to certain events. So you don't have to pay from day one. You can start paying for the storage that you consume as you go on or as you scale. So that's just a Portworx overview. Next, let's talk about, let's double click into data protection or PX backup and why backup is essential for enterprise applications. The first one is data protection. Like, you need backup and restore capabilities for your applications, because preventing data loss is a top enterprise storage concern. Like, this requirement hasn't changed just because we moved to containers. You still need a solution that can help you protect your applications and then recover from failures like accidental deletions, data corruptions, in some cases ransomware attacks. You can use your backup snapshots that are stored remotely or like locally in an S3 compatible object store, and restore your applications to a previously known good state. So data protection is one of the key requirements. Second requirement is around compliance. Again, this, like the text that we have there talks about GDPR, but that's not just the case. Like, there are local regulations based on the country that you're running your applications in, where they have made it a requirement that you should have backups, where like if any disaster happens or if any event happens, you should be able to restore as quickly as possible. The third one is recovery demand. So this goes around the point where enterprises that are running these applications don't want to have really long RTOs or recovery time objectives. They want their applications to come back online as quickly as possible, so that their customer experience isn't being affected. We all know in the world that we live today, the switching costs between applications are really low. So if a specific application or a website is down, customers might choose a different vendor out there and start using that service. So making sure that you have a solution that can help you recover as quickly as possible is another major need. And then the last one is around security, and this is where we have been hearing about ransomware attacks or security breaches, and the number of cases or number of incidents that we hear keep on increasing on a yearly basis or even a monthly basis. And especially given the times that we live in today, security is top of mind for everyone. So you need a backup solution that can help you store these snapshots in a remote location, maybe encrypted, and doesn't allow people to mess with it. So in case of an attack, you can restore from that remote copy and bring your applications back online. But when you're talking about Kubernetes data protection, there are certain gotchas. Traditional or legacy data protection tools that you have been using don't really work with Kubernetes in a seamless fashion. Many vendors out there are trying to retrofit their solutions to support Kubernetes, but still using that traditional monolithic application that they have running in your data center or in your cloud environment. So a few things to look out for when it comes to challenges with Kubernetes data protection. The first one is traditional backup is time consuming. So this is because whenever we are talking about these traditional solutions, they talk to a specific endpoint, right? So if I used to work on VMware solutions for a long time, and backup tools around VMware used to interact with my vCenter instance. They used to do a great job at talking to vCenter, inventorying all the different resource pools and VM folders that I might have, and protect all of those virtual machines and give me the ability to restore from those snapshots. But when we are talking about containers or when we are talking about Kubernetes, that's not the case. Like the way containerized applications or microservices based applications are deployed on Kubernetes, they follow more of a distributed architecture. So not every single virtual machine that you're protecting will have all the different components for a specific application. They might even mix and match, like each VM can have application components running from 4 different applications. So by just protecting the VMs without understanding how the application is actually deployed might not be the best way to protect your application. And in case of disaster events or incidents, you might end up spending more time on bringing your applications back online. Second point is around unable to backup and restore anywhere. So this comes from a need where Kubernetes provides you that consistent layer of abstraction that you can run on premises, on your existing data center environments, or in the public cloud. And you need a solution that's able to adapt to any of these infrastructure needs. So you need a solution that can protect your containers that are running on-prem. You need a solution that can protect your containers running in the cloud. Preferably, these should be the same solution, or else you'll end up creating silos and infrastructure-specific tools. So you need to keep that in mind whenever thinking about Kubernetes data protection. Third is IT dependencies and bottlenecks. This comes from the fact that whenever we talk about enterprises using backup tools, there is a backup admin or a team of backup admins that are responsible for meeting with the application owners and coming up with those SLA requirements and configuring your backup jobs. But with the distributed nature of the applications that are running on Kubernetes, the responsibility for protecting applications has also been distributed across different user personas inside your company. So you might have a DevOps admin or developer who might know how to best protect that application, rather than trying to teach the backup admin how things are configured, what components they should be protecting, and then creating that bottleneck inside your organization. The next couple of points are around difficult to maintain compliance. If you don't have a solution that can help you meet the local regulations, if you don't have a solution that, like the 3-to-1 backup policy, right? That's a popular one whenever it comes, like whenever we talk about data protection or just backup and restore. You should have 3 copies of data split across 2 sites, and then one of those should be stored in an offsite location. So if you can't meet those requirements using your backup tool, might be time for a change or looking at and evaluating a different tool. And then application downtime is expensive. So the longer it takes for you to bring your applications back online, the worse it's gonna get. So whenever we are talking about disaster events, you don't want to be in a situation where when there is panic all around you, you're trying and figuring out, okay, how do I restore applications, or in what order, or which clusters are ready to take these applications and have them up and running. So you should have a solution that helps you bring your applications back online with a couple of clicks without having to go through tedious processes. So that's where PX Backup comes in. So as we discussed in the first slide, PX Backup is that single unified tool that helps you protect your Kubernetes applications end to end. So with single click backup and restore capabilities, PX Backup provides you a simple user interface, something that we look at in this demo today, where you can easily identify all the different applications that you are running on your Kubernetes cluster and create backup jobs really easily. And you can create these backup jobs based on the different Kubernetes namespaces that are running on your cluster, the different types of Kubernetes objects, or even if you have certain labels that you use for your Kubernetes objects or applications, you can use those to create your backup jobs as well. And it's as easy to restore those applications from those backup snapshots as well. Next, we have cross-cloud mobility support. So one of the things that we cover in this demo is how you can leverage PX Backup to move your application or restore your application that was originally running in Google Kubernetes Engine cluster or a GKE cluster and move them to an Amazon EKS cluster. So PX Backup provides you that solution to enable cross-cloud mobility and deliver on the promise that Kubernetes provides, where you can move your applications wherever you want to. Third one is running applications in production with confidence, because this allows any developer or application owners to use role-based access control and protect their applications on their own, rather than having to trust and rely on a backup admin and hope that they created those backup jobs with the correct specifications in mind. PX Backup also allows you to comply with the 3-to-1 backup support. So you can easily store a copy on-prem, you can store a copy off-site in an S3 bucket and comply with that rule. And then if you want that additional level of disaster recovery, PX Backup allows you to meet those RPO and RTO requirements as well. The only gotcha here is if your applications need that 0 RPO, you might have to go to PXDR, but PX Backup should be able to give you a solution that can meet all your other SLA requirements or all the other RPO requirements. So that's PX Backup in a nutshell. It's a single tool that can help, that was built for Kubernetes. It runs on Kubernetes cluster. It can run on a dedicated backup cluster, or it can co-locate and run on the same cluster where you're running your applications. Ideally, you want, like, people don't do that. They run it on a separate cluster. So even if your source cluster goes down, you still have access to the PX Backup interface, and you can use that to restore your applications to a third cluster. So that's PX Backup for you. A couple of diagrams before we move on to the demo section. So whenever we are talking about PX Backup, we have a new release coming out every quarter. So we try to keep up with, or we try to meet our existing customers' demands, while at the same time identifying industry trends and build features into the product that can help you pick PX Backup whenever you're looking to modernize your data protection solution for Kubernetes. So one of the features that we launched in the latest 2.1.1 release was application aware hybrid cloud mobility. And this is where you can have your applications running on any cloud Kubernetes cluster. So Amazon, Azure, or Google Cloud, or even IBM Cloud and on-premises versions. And then for some of these cloud vendors like AWS, Azure, and Google, you don't even need to run PX Store as the Kubernetes storage layer. You can use whatever is native and default to that specific cloud environment. So in case of AWS, you can use GP2 backed EBS volumes. In GKE, you can use the standard storage class that comes installed by default on your GKE cluster. And if you need a data protection solution, you can use PX Backup to protect or backup and restore those applications. And you can also use PX Backup to move that application from one infrastructure endpoint or one cloud endpoint to a completely different one. And hopefully this image helps you visualize how some of these applications are deployed. So you have your green application, your purple application, you can running on a Kubernetes cluster, and you can create backup jobs and then restore them to the same cluster to different clusters based on your recovery needs. So that's an interesting feature. The second feature that we announced in the latest release was support for file system backups. So again, if you're not using Portworx PX Store as the Kubernetes storage layer, and you're just leveraging file systems like EFS backed persistent volumes in your EKS cluster, now you can use PX backup as the data protection tool to protect those persistent volumes as well. So you can try this out with a couple of scenarios. So if you want to continue using EKS cluster with an EFS storage backend, you can do that. You can leverage PX backup to backup and restore to the same cluster. But like if you have watched any other demo, you would like to try PX Store on an EKS cluster so that it can provide a single unified storage solution for your block and file needs, you can still do that. You can use PX backup, protect the applications that you have running on EFS, and migrate those to a Portworx enabled EKS cluster easily with PX backup. So that's another scenario that we look at today in this monthly demo as well. So with that, I think those were all the slides we had for you today, apart from like the architecture slides and how to follow up slides, but that's it for the slides. We can now jump into the demo piece where we can cover a few different scenarios. So the first scenario that we have for you is that cross-cloud application portability, where we have an application that's running, a very simple application, a UI-based application that's running on my GKE cluster, which is consuming local storage from the standard storage class that's configured on GKE clusters. And then how we can create a backup job for that application, protect that application, store those snapshots in an Amazon S3 bucket. Again, you can store it in a Google Cloud Object Storage bucket or an Amazon S3 bucket, and then how you can use that backup snapshot to restore the same application to your Amazon EKS cluster, again without PX Store. If you just want to consume the GP2 based AWS EBS storage backend, you can do that using PX backup. So let's look at that live demo, and then we'll talk about the other two scenarios that we wanted to highlight today. So here we have a PX backup instance running. Here, as let me zoom in. So here we have two clusters added. The GKE cluster is running version 1.21. EKS cluster is running version 1.20. GKE cluster is running in the US East 1 region for Google Cloud. EKS cluster is doing the same thing, but running in US East 1 region of AWS. And then if we look at additional cloud settings that we have configured in this environment, you have those cloud accounts definitely associated, but we also have that S3 based backup repository and object storage bucket that's encrypted on the backend. So all your backup snapshots are also encrypted, and that's available to store your backup snapshots. In addition to this, like we have also configured a bunch of schedule policies. So this is something that the admin can customize on their own. Like if you want to create new backup schedule policies, you can just give it a name and then select whether you want to create a periodic backup policy. So every hour, every 15 minutes, every 8 hours. If you want, let's do one for 8 hours and 0 minutes. Or you can do one that runs on a daily basis, one that runs on a weekly basis, one that runs on a monthly basis. Again, our documentation talks about how these work, but should be pretty straightforward. So once you have selected all the correct settings that you want, you can just hit create, and that backup policy, schedule policy, is now available for any application owner or DevOps admin in your organization to leverage for their backup jobs. In addition to this, PX Backup also provides application consistency by using pre and post exec tools. So this is where you can create your own shell scripts where they can run on your containers before the backup is taken. So instead of it being just crash consistent, now your backup snapshot is application consistent. And then so we basically acquires the IO. And then to restart, like once the backup is done, we also resume operations. So you can have pre and post backup rules for individual different stateful database that you might be running in your environment or as part of your different applications. So that's with like the initial settings that you have configured. Once, let's look at our demo application, right? So we have two tabs here. This is my GKE cluster that is added to my PX backup instance. So if I do a kubectl get nodes, you can see we have a 3-node cluster that I deployed this morning for this demo, running version 1.21. And if I look at all the different things that are running in my demo application, you can see we have a couple of pods, a couple of service objects, and then those pods are deployed using deployment objects. This is a stateful application. So if you do a get PVC, you can see that we have a Postgres backend, and it's mapped to our standard storage class, which comes by default in a GKE cluster. And it's providing that persistent storage to my application. To access my application, we have provisioned a load balancer endpoint for the service. So if you just navigate to it, you can see that this is a simple application where based on the click, wherever I click on the screen, it generates a data point, stores those pixel coordinates in the Postgres backend database. So when we back this up and then we restore it to the EKS cluster, we can verify that the restore operation worked successfully. So let's go ahead and create a backup job and see how easy it is to do all of this. To create a backup job, all you need to do is select the GKE cluster. Here you can find a list of all the different namespaces that are running on your GKE cluster. We have deployed all of our resources in the demo namespace. If you wanted to, by default, the backup job will include all the different resources that it finds in the namespace. But if you wanted to pick and choose, if you just wanted to backup persistent volumes, or if you just wanted to backup service objects, you can go ahead and customize your backup jobs as you want to. But in this demo, we'll select all resources. In addition to the resource type, if you wanted to specify additional labels, if you had some demo label or some label associated with your different application objects, you can go ahead and set that as a filter as well. Honestly, I didn't configure my application using any labels, so I won't use that, or else that backup snapshot won't really have anything in it. Once you're ready, once you have selected all the right objects, you can go ahead and create a backup job. So for this, we'll give it a simple name, monthly demo backup. We can select a backup repository. So in this case, our backup snapshots are stored in our S3 repo. We can create on-demand backup jobs. So these will be ad hoc. So once ran only once as soon as I hit create, or I can also create them on a schedule. So this is where all the different schedule policies that we saw earlier show up. So I can do a 4-hour one, an hourly backup, daily backup, or the test demo one that we did, which runs it every 8 hours. For this demo, again, I want to keep it simple. I'll do an ad hoc one. And then in addition to schedule, I can also select the pre and post exec rules. So here, this is where you can find those details. Once you have everything configured, you can just hit create. And at this point, PX backup talks to a Stork instance. It's just a simple, not even an agent. It's just one pod per node in your application cluster. PX backup talks to Stork, asks it to create that backup job locally on the cluster. So it identifies everything that was selected as part of your backup operation. Starts by first creating a replica or creating a snapshot of the persistent volumes, stores that in the S3 bucket, and then once that's done, it basically goes ahead and copies all the different application objects. So on the CLI, we saw that our application had a couple of deployment objects, which resulted in a couple of pods. We had a couple of service objects. So it basically creates a snapshot to include not just my persistent volumes, but also all of these different Kubernetes objects that make up my application. As you can see, we have had a few backup jobs already running throughout the day. I had one created to run every hour. So you can see those already existed. Here, so the monthly demo backup job that we just created completed successfully. It copied over one persistent volume and 7 different Kubernetes objects. If we go ahead and look at show details, this is where you can find out additional details of the things that are backed up. So It protected one config map, a couple of deployment objects, persistent volume claim, and a couple of service objects. So all of this is included in that backup snapshot and can be used to perform that restore operation. So before we do the restore, let's just look at our EKS cluster. Here we have a similar, I think it's a 3-node cluster. Yep, it's a 3-node cluster that we deployed this morning. And if we do get namespace, you can see that we have a demo namespace ready for you to go, ready for you to use for the restore operation. And if we do a get all in the demo namespace, you will see that we don't have anything running in the restore cluster or on the EKS cluster. So anything that we deploy or anything that gets deployed will be because of the restore operation from PX backup. Another thing to keep in mind is we will be using local storage. So here in this case, we'll be using GP2 as our storage class to dynamically provision those EBS volumes when we need to restore our application. So let's go ahead and initiate that restore job. It's as simple as coming to the UI, finding that backup snapshot that you want to restore from, and then hitting restore. We can just give it a name, so demo restore monthly, and then here you can select the destination cluster. So you can either restore it to the same GKE cluster or you can restore it to a different EKS cluster. Here you can do a default restore where we basically copy everything that's available in the snapshot onto your destination cluster, or you can also choose to do a custom restore. So here you can select things like, okay, the standard storage class that existed on my GKE cluster definitely doesn't exist on my EKS cluster. So I have the option of selecting which storage class I want to use. By default, if you don't specify anything, we'll just use whatever is available as the default storage class in your recovery cluster. Same goes with namespaces. So if your application was running in the demo namespace on your GKE cluster, but now you want to restore it to something else, you can go ahead and do that as well. And then again, since we are restoring our application as a whole unit, you can keep all of these boxes selected. But again, when we are talking about the ability to customize and use PX backup based on how your application demands, you can perform these restore operations and only choose to restore deployment objects or service objects or persistent volume claims as part of your application. Once you have selected all the right things, you can go ahead and hit restore, and this initiates a restore operation. So similar to how we did the backup, where PX backup communicated with Stork and asked it to perform our backup job, the same thing happens here, where PX backup now talks to Stork running on the destination cluster and asks it to perform that restore operation. If we log in, if we access the cluster again and do let me do a watch command on the demo namespace. Okay, here you can see that we basically create a new Kubernetes job for the restore operation, where this pod is now responsible for pulling that backup, pulling the data from the backup snapshot that's stored in Amazon S3, and then it will start creating those persistent volume objects. And then once the persistent volume is fully created, it basically goes ahead and creates our deployment objects and our service objects. Similar to how it was running in GKE, where the front end had a load balancer endpoint, does the same thing here on EKS because it copies over all those settings. So if we just do a plain or kubectl get all instead of a watch command, you can see we have two deployment objects, two service objects, two pods running. If we do a kubectl get pvc in the demo namespace, you can see that a persistent volume for our Postgres database did get created using the GP2 storage class that was available on our EKS cluster. So once all of this is ready, what we can do is basically use this load balancer endpoint and try to access our application now that it's running on EKS. So once the application is fully restored, again, like similar to how you can look at details for the backup job, you can use the PX backup UI and look at details as part of each restore operation as well. So here you can look at things that you had customized, so which namespaces were being used to backup and restore, what different resources were used to protect our application. So a config map, a couple of deployment, same resources that we saw on our source cluster are now available on our destination cluster as well. So you can find those details from the PX backup UI. Let's try to navigate to our load balancer or ELB endpoint and see if our application is now back up and running. As you can see, the different data points that we had on our source cluster, which is again still running. So you'll see that this IP address based application is running in GKE. And if you see the EKS cluster is an exact mirror of the locations of those logos and the database record, number of database records as well. So this is how easy it is to move your containerized applications across different public cloud environments. So you saw like I didn't have to do anything specific in terms of customizing for that specific cluster. Like PX backup was able to understand that, okay, the source cluster was GKE, destination cluster is EKS, and make all of those changes that were needed to restore my application successfully on the destination or on the EKS cluster. So that was my first demo for you. Let's go back to the slides and we can look at the additional couple of scenarios that we wanted to demo today. So the second demo that we have today for you is a scenario where we have a simple application that's running on, again, in this case, the application is Jenkins. So how a Jenkins application that's running on an EKS cluster, and it's using persistent volumes backed by Amazon EFS, and how we can use that to not just back up and restore to the same EKS cluster. We'll also look at how we can use that backup snapshot to migrate my application from an EKS cluster that was running that was using EFS as the storage packet and move it to a new EKS cluster that is using Portworx as the storage packet, and how PX backup allows you to do that. So for these, we don't have live demo environments. I would rather do a demo, a recorded demo for you, and we can talk through it. So the first one is where we have an EFS Jenkins running on an EKS cluster backed by EFS, and we are just restoring it to a different EKS cluster, but still backed by EFS. So as part of Jenkins, we have a pod, a deployment object, a service object. We have a persistent volume that's backed by the EFS-demo-SC storage class, and this is an EFS storage class that allows applications to dynamically provision, read write many persistent volumes to leverage. As you can see, the provisioner is efs.csi.aws.com for that storage class. So it's using EFS as the storage backend. And Jenkins-home-pvc. This is the persistent volume that basically gets mounted inside the Jenkins pod at the Jenkins home directory. So any plugins that you download, any specific customizations and configurations that you do inside Jenkins, the user credentials that you create, the pipeline objects that you have created, all of this data is actually stored inside that Jenkins home directory, which is backed by a persistent volume. So when we restore it to a new cluster, we should be able to log in using the same credentials, find the same plugins that were installed on our source Jenkins instance. So now that we have verified that, let's do a couple of things. Let's go ahead, we'll also go ahead and look at the UI for Jenkins and see all the different customizations that we have done. So here we have a Jenkins instance running, and my username for this Jenkins instance is Bisha, and we have attached a custom header message. We have created a couple of demo pipeline and demo projects as part of freestyle projects as part of our Jenkins configuration. We also have configured or downloaded plugins that are necessary for running containers and Kubernetes, or whenever you're using Jenkins for those kinds of workloads or applications. So if we just do a search for Kubernetes, you'll see a list of applications that I have installed on this Jenkins instance that makes it such that I can use it to run CI/CD pipelines for my containerized applications. So ideally, we have seen customers who, when they want to share these environments, just give a need to capture the state of this Jenkins installation and restore it to a new cluster. So for that, what we can do is use PX backup for that use case. So here, similar to our live demo, we have an AWS cloud account and an S3 backed backup repository configured inside our PX backup instance. And we have a couple of clusters. We have our source EFS cluster that's running version 1.18, and we have a Jenkins restore cluster, which is another EKS cluster, but that one is running version 1.20. So this also helps us show the value of PX backup and how it can help you move your applications across EKS clusters that may be running different versions of EKS of Kubernetes. So our Jenkins instance was running in the Jenkins EFS demo namespace. So we select all resources in that namespace, and we can give our backup job a name. We can select the backup location. We can again choose to do it on a schedule or do an ad hoc backup job, and select pre and post backup rules if I had to. Once we hit create, PX backup basically initiates that backup job and creates a copy of my Jenkins application, stores a snapshot in the S3 bucket repository, and allows me to restore from it once it's successful. While we wait for the backup job to be successfully completed, from the PX backup UI, you get this backup timeline view where if you are an admin or even an application user, you can log into PX backup and get a view of how your backup jobs are doing. So if things are not going well, you'll see this exclamation mark. So which means that, okay, maybe your backup has failed, go ahead and fix it because you want to comply with those SLA requirements. And you can go as far back as 30 days, or you can get a more detailed view for the last 24 hours as well. So now that our backup job is successful, we can go ahead and restore from this application, from this backup snapshot. As part of this backup, we have a deployment object, a PVC, a PV, and a service object that were all included in that backup snapshot. And then if we do look at the destination cluster, if we delete the application completely, we can let's go ahead and do that using our YAML file for that Jenkins EFS demo namespace. So we deleted everything. It takes a few seconds for the service object to get deleted because it's connected to a load balancer instance in AWS. So that's what takes the most amount of time for the delete operation to complete successfully. Once that's done, let me just fast forward this a bit. And if we look at all the different resources in the kubectl in the Jenkins EFS demo namespace, you'll see that we don't have any. If we look at PVCs, again, you shouldn't find any existing PVCs before the restore operation. So here we have an environment where you accidentally deleted your Jenkins installation. So to perform that restore operation, we can give the restore job a name. We can choose a destination cluster. In this case, we are restoring it to the same cluster instead of migrating to another EKS cluster that is backed by Portworx. You can select the storage class. You can select a new namespace for it if you want. So in this case, last demo we saw, we restored it to the same namespace demo. In this one, we'll mix it up, use a different name for a destination namespace, and then we'll wait for the restore operation to be successfully completed. So it does the same thing, talks to your destination cluster, initiates the restore operation. And in this case, instead of creating a read-write once volume using GP2, it's creating a read-write many volume using the EFS storage class on the backend. So once that's done, completed successfully, you can look at show details, find out all the different things that were restored in that namespace. So 2 resources, 1 volumes. If you do a show details, you can look at all of those details from the UI as well. And you can also look at those resources from the CLI using the same kubectl command. So kubectl get all, get PVC. You can find out the load balancer endpoint for the restored Jenkins app. And once you navigate to it, you should be able to log in using the same username and password. So Bisha and the password that we had used for our original application. Sign in, you can see this, you should be able to see the same artifacts that have been created inside Jenkins. You can see the same name, the same custom banner, and then we want all the different plugins to be running on our restored application as well. So people who have used Jenkins before know that installing and maintaining all the different plugins that are custom for an environment is a pain. So having the ability to restore a new instance of Jenkins and still have all of that information or all of those plugins installed is going to be a difference maker and save you a lot of time. So that was one demo. The second one, we go through a similar workflow to create that backup job, but instead of restoring it to an EKS cluster with EFS backed storage, we see how you can use that backup snapshot to migrate it to an EKS cluster with a Portworx storage backend. Here we have the same installation for Jenkins, a deployment object, service object, persistent volume claim, and then persistent volume claim is backed by the EFS demo storage class. It's the same setup, but we can skip ahead and just look at the restore operation because we use, like we walked through the same things that we walked in the previous demo, like looked at all the different plugins that are installed, and then create a backup job. Once the backup job is completely successful, let me just skip to that point where the backup job is fully up and running. Okay, so backup job has been successfully completed, and we have a backup that's stored in Amazon S3. At this point, what we can do is log into our second EKS cluster, which is running Portworx, and we can make sure that the namespace that we want to leverage doesn't already have any resources. So in this case, we are doing a kubectl get all and kubectl get PVC in the Jenkins restore namespace. As you can see, nothing's available. We can do a kubectl get storage class, and here you can see that there is a read write many storage class called px-shared-sc that's created for you on the destination cluster, so that whenever you perform that restore operation, you still can provision a volume based on a read write many storage class. So let's go ahead and hit restore. We'll do a similar workflow. We give the restore job a name. So in this case, we're restoring it to a Portworx cluster, so we'll name it something specific. We select the Jenkins restore cluster instead of the EFS cluster. We'll do a custom restore because we want to change the storage class. Instead of EFS demo SC, we want to use the px-shared-sc storage class. Names from a namespace perspective as well. Instead of using the Jenkins EFS demo, we want to use the Jenkins restore namespace to restore our Jenkins instance. And we want to restore everything that's included in the backup snapshot. So we'll keep all of those boxes selected as well. Well, once this is like everything looks good, you can hit restore, and PX backup will initiate the restore operation for you. So this is where, again, it starts by deploying your persistent volume backed by the new storage class and coming up and then deploying the deployment and service objects. From the CLI, we can do a kubectl get pods in the Jenkins-restore namespace and do a watch command on it. So once the pods start coming up, we know our application is being successfully restored. So you can see our pods go from pending to container creating to running states as part of the restore operation. And then we can find out about all the other objects that were part of the backup. So do a get all, and you'll see a new service endpoint. If you do a get PVC, you will see a new persistent volume being deployed for our Jenkins instance using the px-shared-sc storage class. So this is how we use PX backup to migrate applications not just between different EKS clusters, but also between different storage backends. So that's another value that we discussed initially in the slides, right? Like how you can leverage PX backup on any infrastructure, and you can how you can use PX backup to move your applications across any infrastructure. These can be different Kubernetes backends like GKE and EKS, or it can be completely different storage backends from cloud-specific block storage classes or file storage classes. So hopefully these set of demos gave you a good understanding of how PX backup can help you with your modern Kubernetes data protection needs. While we are going through this, let's just make sure that we can log in to the Jenkins instance using the same set of credentials, and make sure that all the plugins and configurations and customizations that we did still exist. So we can see the same artifacts, the same banner message. If we verify the plugin, so clicking on Manage Jenkins and Manage Plugins and search for Kubernetes, you will see the list of same plugins being deployed on this restored Jenkins instance as well. So that's it for the demo. Time to, I think, switch it back to slides. We have a couple of slides before we can see if you have had any questions. I'm sure like Ryan would have taken care of those. So let me switch to slides now. So one thing before saying thank you was, if you like this demo and you wanted to try PX backup, if you wanted to give this a shot, PX backup, you can get it as a free 30-day trial using our website. You can find it easily, or you can go to central.portworx.com, and that's an easy way to create an account and get 2 set of commands to install PX backup on your Kubernetes cluster and start using it to protect your applications. So that's available. Last month, we also announced early access program for PX backup as a service. So instead of installing PX backup on your own, you can now leverage a SaaS control plane for PX backup and just add your cluster, we'll inventory your applications and help you protect those. and you can register for that early access program using the link. So it's simple, portworx.com/backup as a service or BAS-EAP. That's available. Or like if you are really convinced and want to get started with it, you want to skip the 30-day free trial, PX Backup is also available through AWS and IBM marketplaces. So again, if you want to get started with it without talking to anybody from our sales team, you can go ahead and skip that and just use the marketplace offering to get started with Portworx PX Backup. With that, I'll put my last slide on the screen and we'll see if you have any questions. If people want to drop, if they don't have any questions, thank you so much for your time today. We really appreciate you joining us for this hour and giving us this time to talk about PX Backup and how you need a modern data protection solution when it comes to containers and Kubernetes. So Ryan, do we have any questions?
We did have a number of questions. Most of them should be answered. So thank you, Keith, Nerlep, Paul, and Yang for asking questions. Hopefully we answered all of those. If you do have any clarifying questions or new questions, feel free to put them in the chat or the questions or raise your hand. We do have a few minutes left here. If not, thank you again.
And thank you, Ryan, for answering those.
Oh, you're welcome. Okay. Checking the chat. Looks like we're good to go, Bobbin.
Awesome. Thank you, everyone. Again, if you registered for this, you should get a link to the recording. In a few days, you'll also see this show up on our YouTube channel. So, and we have all of our previous monthly demos on it as well. So if you wanted to catch up on recordings, you can go ahead and do that. Thank you again for your time.
Yeah, and you're welcome, Yang and Paul. And good luck. Let us know if you need any help when you're deploying. All right.